Alright, time for another draft. Physics.com video presentation. Debate physics also. And so now we maybe have some debate video. Let's see. And Gostling has made a video where he's going to explain inertia angrily. How exciting. And so this is what he's going to explain. Okay, is in pieces. Apparently. We'll see what he's going to explain. We don't really know what he's going to explain, frankly. What the hell is with this? Let's see if I move it over here. That just doesn't work. That's way too close. This is way too uncomfortable. I guess there's no way to fix that except to turn the camera at an insanely stupid angle. Alright. So, we have his clay experiment that he didn't video because the results came out confirming my theory that you drop a 1 mass from 4 times the distance, and then you drop a 2 mass from 1 unit of distance, and it produces the same impact force. Crushes clay the same. So it's very similar to this argument about a lever. You know, that basically if you're going to push on a lever, the 1 mass will weigh the same as the 2 mass. The 1 mass of twice the distance weighs the same, same pressure. And if something's going to apply a force to it, well, it really can't tell the difference between the 1 and the 2. They're going to feel exactly the same, unless the lever's doing something pretty funky. And then you have the other experiment, the 5-ton train going 10 miles an hour being converted into a 10-ton train going 5 miles an hour, and you perfectly conserve all of the momentum, but you lose half the kinetic energy. So in this case, you lose half the kinetic energy. In this case, you lose half the momentum, when he did it anyway. And in this case, you lose half the kinetic energy. So these are all violations of basic conservation law. I mean, I could play the Feynman video where he talks about the law of conservation, and the energy's like little blocks, and you always have to account for where the blocks go. Well, this KE versus momentum thing doesn't work too well because apparently both theories fail to conserve. And that is, in my opinion, a big problem. So let's see what his response is. I mean, he was quite confident that the clay experiment is broken. I'm quite confident that this lever experiment, this catapult experiment he's done, is quite broken. That the flaw can be found if you're willing to look for it. Let's see if he's willing. All right, pretty much. But really, explaining what inertia is mass. Inertia is something's weight. Frankly, that's all inertia is. And a half mass, twice the distance on a lever, is the same weight. It's producing the same resistance to motion. It can't produce more resistance to motion. It's half the mass, pretending to be a full mass. It can't really produce extra heaviness. It's just so ridiculous an argument, frankly. They should know that, wow, that is kind of stupid. It probably isn't the truth, okay? That somehow the lighter thing is harder to push? Come on. That doesn't make any sense.
There's no bending of that lever, Gary.
Look, whatever. Do the experiment, okay? So he's just going to say it instead of doing the experiment. It's simple enough experiment. Let's see it. Ugh.
Rigid as. Look at the cross-section.
You're boring me. I can show the video from your first test video, okay? If you do frame by frame, you can see the lever bending. So let's not pretend this is indestructible. Ugh. I mean, it could be the camera that was causing that, but who knows?
On your previous video, when you asked so nicely that I would redo this experiment, you said, well, we'll see. Either I'll win a battle or you'll win a battle, not the war.
I said that about doing the moving the same weight experiment, you dumb fuck. Oh, God.
I've obviously won a battle here. So
No, I didn't. So you haven't even got that context right. I said you should redo the experiment instead of trying to reclimate two shitty camera angles. I did not say that the experiment's going to come out my way. I didn't say that. I used the numbers 85%. Remember the number 85%? I'm saying that's how much energy you could expect to get. Let's just saying for losses from the lever. So you can put the 2 mass anywhere on the lever, and the most difference you should get in its velocity is 85% slower. That's it. It shouldn't matter where you put that 2 mass on that lever. It technically should leave at the same fucking speed, moron. Oh, so he does. I made the video twice. I twice explained to him the experiment. This, I have to rub it in your face. You're just like a dumb little dog or something. I gotta rub your nose in your mess. This right here. This. There's no other mechanism. All there is the spring. There's no reflection to take away energy. There's no other place to lose the energy. Theoretically, it doesn't matter where the 2 mass is here, the 2 mass is here, the 2 mass is here. The spring can go shoot it fast, or the spring can shoot it slow. It can regulate how fast it moves. So if it's way out on the end, the lever moves slowly because the arc is large, so the whole lever can move slower. Or if it's real close in, then the spring can jerk real fast, okay, move the whole lever real fast and move the object at the same speed. I mean, I went and explained this. I mean, the lack of attention span here is amazing. Ugh. Well, obviously he's not going to explain inertia. It's a 5-minute video. No chance.
Please. Have a little bit of, admit that. Say thanks for doing the experiment, Ian.
Oh, please.
Thanks for the time and the
you.
trouble.
Oh, fuck you,
And
fuck you, fuck you. Okay, I did it on my porch. It's not that much trouble. All right, and I'll do it again as stated. All right, if you don't like doing the experiments, then just be like me and say, I don't want to do them. And don't do them. Okay, don't pretend you're going to do the experiments and then just bitch like somehow this is a terrible obligation you have. I think it's a terrible obligation because motherfucking goddamn you cunts defending classic physics, they haven't done any of these fucking experiments. They never bothered to see how much fuel it takes to go twice as fast or 4 times as fast or 10 times as fast. They never bothered. For fuck's sake, you keep defending physics that's outrageously incompetent and underdone. All right, and I'm the one saying, why the fuck should I have to do a lever experiment? In 350 years of your stupid kinetic energy theory, your people can't do a fucking lever experiment? I mean, fuck you.
Yeah, okay, it's come out your way. I concede.
I'm not conceding anything.
But I don't get any of that. It's all, let's see if he'll do this. Let's see if he'll do that.
Let's see if there's a flaw in your fucking experiment. So again, I'll just point out this fucking coward, this crook, this shyster, this liar, okay, didn't show you the clay experiment. He hid it. Okay, so this lying piece of shit who's telling me I have to concede, he wouldn't concede that his fucking clay experiment didn't come out his way. What did he do? He made a video saying, we have to figure out why it didn't come out my way. We have to figure out what went wrong because it came out with his theory is correct. You didn't fucking present the evidence and show it, you fucking lying piece of shit. So don't play this hypocrisy game, you fucker. What did you ever concede, you fuck? Are you willing to concede that Leibniz was wrong? Are you willing to concede that de Chatelet's clay experiments were moronic? No, you fucking piece of shit.
He's cheating and he's, why would anybody bother with you?
I didn't say you were cheating. I said, why the fuck would some idiot, when the experiment took 5 minutes, as you just showed because you redid it, takes 5 minutes, why would some fuck tie the weights in arbitrary places and then claim that's the experiment? There, I fixed the camera angle. That doesn't fix the camera angle, fuckhead. Why would they bother with that? Why wouldn't they just redo the experiment? I asked the question now 6 times at least. Maybe you should just answer the simple question. Why would you bother trying to reclimate 2 poor camera angles when it'll take a lot less time to just redo the experiment.
You don't know how to behave with people. You don't know how to behave in
I
a
couldn't
decent,
give a fuck. That's
respectful
right.
manner, do you?
No, I don't. I just couldn't give a shit.
So come on, let's
I
have a
don't
little
owe
bit
you any
of
respect, you
acknowledgement
fuck.
of what you wanted. You wanted me to redo this test, different camera angles.
I said do it with the right camera angle. I didn't say different ones. Do it with one that's rational. Fuck.
You made a big thing of it, so I've done it. And there's not a word, not a mention of it. You've gone on to the next excuse.
Whatever. Again, don't do the experiment, okay? I couldn't give a fuck about your stupid crap experiments, just like Dispar's crap experiments. I'll have to do them right, because you couldn't give a fuck about trying to figure out why it's doing something that, it just isn't quite right. It's like Brozo, when you get an answer that's right in between the two fucking theories, it should occur to you that maybe I should investigate and figure out why I'm getting a stupid answer. But no, you're not interested in the physics, you fuck. You're not interested in the theory. You're not really interested in this subject. You're just interested in trying to say, Gary's wrong and I'm going to prove it. Well, I'm not wrong and I'm going to prove you what you are. A fucking goddamn advocate for flat earth bullshit. Okay, you're just defending an old theocracy.
And it's all ridiculous, all of this, Gary. You're saying, how does the lever know the difference?
What the fuck is this going to have to do with a lever? Amazing.
With one weight, one distance, or half a weight, two distance. It doesn't know. It doesn't know when it's in a static balance. Of course not.
Oh, well, how does it know when it's in an imbalance? How can it tell the difference at any point when it's pushing it? How does it change anything? It's always twice the distance away. How does it ever change how much it weighs or how much resistance it has to motion? It can't change that. That's what I'm asking you to explain. Exactly how does it change it when it doesn't change its distance from the fulcrum? How the fuck could it possibly change its weight? Jackass. I mean, obviously, another thing I didn't point out, but is probably part of this problem, it's just like when, there was a problem, okay, with using the linear track. Okay, so let me draw that. I mean, you really just don't care about any of these details, okay? You're going to keep pretending they don't matter when, of course, they do matter. It's critical to what science is investigation. And you're just not interested. All right. So in the physicist Michael experiment with the tracks, obviously it's a problem. I mean, I had it with my pendulums, and they weren't like yours. They weren't two strings, okay, tied to something. So almost like the track argument, your two-string pendulum, the liability is that it really does force it to go in one direction. It sort of obligates this direction thing. And you do know that when the lever's turning, it's turning this way. So this line has an angle to it. So when it's actually pushing, it starts off pushing from twice the distance. And as it gets further and further into the pushing process, this isn't twice the distance anymore from the fulcrum. This is now twice plus point whatever, 4 or 3, right? You've added extra distance that it is from the lever. And what does that mean? It means it's getting heavier as the lever's pushing it. Can you understand that's a real fact? So as this lever starts off, it's twice the distance here. So let's just say it weighs 2. You know here it weighs 2 plus. And here it weighs 2 plus plus. Because it just keeps getting further and further and further. If you could make it infinitely long, you can kind of get the point that this line keeps getting longer and longer. So technically it's getting heavier and heavier as the thing is being pushed. That's a liability, right? So the idea would be, as I said, for Brozo's experiment even, that maybe we have to put a fixed thing that prevents it from sliding out on the lever. So it's forced to stay in this path. And yes, it'll be thrown in the wrong direction. But obviously your pendulums can't be thrown in the wrong direction. Just a fact. These are the details that matter, and you just, like I said, you just couldn't care less about paying attention to any of it. And so, again, the simple argument is where is the lost momentum going? Where is it? The Feynman argument. You've lost half the blocks of energy. Where did they go?
We're not talking about a static balance here. That's a static balance.
Again, how does it matter? What's the difference? If I move it a millimeter, 2 millimeters, 10 millimeters, it doesn't matter what point I'm pushing it. I'm pushing the same weight every time I'm pushing. The weight doesn't change if it stays, again, on that side of the lever. But we know as the lever turns, it's changing the position of the mass. Just a fact. So instead of doing the simple experiment of just putting the same mass there, then put it there, then put it there, and then put it there, put it in 4 positions, just even 3 positions be good enough. Put it here, put it here, put it here, and see if it moves at almost the same speed. And what you really find out is, if out here it moves really slowly, then you know your lever is bending.
I'll try not to swear. That's a dynamic aspect. You keep it
means nothing. What does that even mean? So what? It's dynamic. How does the weight change? That's like saying I'm lifting something. I lift this pen. Is there some point where the pen gets heavier? It weighs the same here as it weighs here, as it weighs here, as it weighs here. It's a bunch of mass, and I'm going to push it. If I'm sliding it sideways, you know, if I push it and I push it and I push it and I push it, does it get heavier? No. It doesn't get any heavier. I mean, it's just a pile of crap. You're talking shit. I mean, throw it in space, it's even better, right? Because obviously rolling it, pushing it on a surface, you know, friction gets less the faster I push it. But in space, it's not going to be that way. Do you really think when I'm pushing something in space, it gets heavier and heavier as I'm pushing it? Bullshit.
Nor in the dynamic aspect. Well,
there is no dynamic aspect, so draw me a picture of the dynamic aspect. Show me how something changes its weight, its atomic mass. How does it change its atomic mass, you know, to create inertia? Extra inertia.
Weight is here, or half a weight is there. Here, there, everywhere. Shake it all about.
Whatever.
Whether it's here or there, in a static sense, it weighs the same.
Oh, I mean, this is just absolute bullshit. So we know it doesn't. Weight is different than mass, okay? Its mass is the same. Its weight is different because it has to push it, okay, from a fulcrum. And the fulcrum is what's going to feel the weight. It's going to convert it, the pressure from one side of the lever to the other side. So, bullshit.
It's only when it's being accelerated that there's a difference.
No, there's no difference. And again, where's your explanations? You're not explaining anything. Where'd the momentum go? You lost half the momentum. Where did it go? Where's the magical place that the momentum went?
How does the lever know? How does the spring know, you say? How does the lever know where the weight's placed?
How does it know the difference between the pushing torque? The pushing torque is exactly the same for the 2 mass half the distance as it is for the 1 mass at twice the distance. The pushing force is exactly the same. The resistance to you putting pressure on it is exactly the same.
Here we go.
Absolute fact. That's why levers work. is because you can do this thing where you just decide to throw half the mass twice the distance, and you'll be able to lift it as if it was one mass at one distance.
Well, I'll fucking tell you. Come on. That fucking weight, when it's up the end, has got little fucking wings on it.
Alright, so this is his fucking answer. So this is what you get. So you don't have an answer, so you're just going to make up some faggoty little story. And you're going to waste my time with that. Fuck you. That's why I say fuck you to you. What use are you? You make absolutely zero sense, okay? You can't logically defend any of this crap, and you're only in this ball game because you hate me. And those are all just real facts. As soon as if I disappeared from this argument, you would disappear from this argument.
Flapping like fuck. Slowing the fucker down. Imagine it however you fucking like. Inertia. There's a little propeller fucking blowing it this way while you're trying to fucking...
Alright, so this is what he's wasting time with. 5-minute video, and he's going to waste most of it talking about wings and propellers. And then you wonder why I hate your fucking guts. This is why I hate your fucking guts. Because you can't really explain why you're in this, why you're doing this. You don't understand the subject. You can't competently argue it or explain it. And again, you're just in it for one reason. Hate. And nothing else.
Accelerate it that way. It's the inertia. Oh, you silly cunt. You really are. Yeah, you're getting me going. Now listen. We don't know what the inertia is. Like, we don't know what the gravity is. You can have a thing.
So inertia's a force now. It's a force all of its own. It's a powerful bent space thing or something. The inertia. He's comparing it to gravity. He's comparing it to an active force. He's saying there's some mechanism that's actually called the inertial force that somehow makes lighter things not go fast. Oh, please. Too ridiculous.
Very fine little fucking bullets shooting through space. Lovely. Science doesn't say it knows what inertia is, doesn't say it knows.
No, nobody knows because nobody even makes your argument. Frankly, if I went out and I asked a bunch, what do you think? You want to make a bet on it? I ask a bunch of people, like engineers, I ask them, what do you think happens with a catapult when I put a half mass twice the distance? How many of those people do you think are going to answer, oh, it only goes 0.4 as fast? Yeah. It doesn't go twice as fast. It only goes 0.4 as fast. Yeah. Completely ineffective. You know, shooting light things fast doesn't happen, so don't even try it. You lose half the momentum of your catapult. Half the momentum of your catapult is lost if you put a light object further out. Yeah, half the energy. Don't you trebuchet. Your trebuchet is, oh, you know, you're going to waste all of your energy. It's not going to work. It's not going to conserve your momentum.
Knows what gravity is, doesn't say it knows what electromagnetism is. That's just theory.
Oh, God, this is just so much bullshit. They obviously have a whole pile of crap theory. You're the one who doesn't know.
Theories. We know how to measure them. That's the difference. But there is.
The whole point of this argument is this has never been measured. You can't even get this right. They know how to measure it. When did they do that? When did they measure how much fuel it takes to go 3 times as fast? When did they show us it makes 9 times the damage? When did they do any of that? When did they show us where the 10-ton train, when I make a 10-ton train, I lose half the fucking kinetic energy? Where did it go? I didn't lose any momentum, yet I made sparks and I made sounds and I blew up I dented everything and banged everything to pieces, but I didn't use any momentum to do it. I mean, come on. This is completely undiscovered territory. They haven't even gone close to looking for the truth.
And I do have a fucking camera stand, you cunt.
Look at that. He has one and he's
stuck in a
bitching.
fucking tube trying to get the level.
He's bitching that he can't get his camera to the right place and it's going to fall over any minute and blah, blah, blah. All these excuses, and he has one. it's too ridiculous.
Was right. You're such a wanker, you really are. Fucking wanker. Now you listen fucking here. I'm not talking to you.
Great.
I'm talking to your fucking supporters.
Yeah, fine.
There might be some hope that they can be set free from their fucking mind control. And be honest. I do, I want to help them.
Alright, they're going to find it very unimpressive that you just wasted time doing this when all you had to do was put that 2 mass, just put it out where you put the half mass. Just put it right out there, do the experiment, see how far it goes. Not asking too much. Go ahead, see if it goes the same speed. This is frankly supposed to go about the same speed. And if it doesn't, then you know your lever has a problem.
I'm going to fucking demonstrate the inertia. Silly fucking cunt. What's this weight say? Can you see it? I don't suppose you can.
I'm totally uninterested.
You can't. It says 1 fucking kilogram because that's a fucking 1 kilogram weight. If I lift this weight up and dropped it, you'd expect this fucking scale to come down, wouldn't you? Of course it would. Right?
Depends on how fast you drop it.
When I lift it slowly, it doesn't move, does it? It stays on the 1 kilogram. If I accelerate...
Yeah, okay. If you accelerate it, yeah, that's right. If you move it faster.
Break my hand up so that the weight is being accelerated up. And then I catch it. I'm going to catch the weight so you can't say, oh, well, the weight's dropping down. I accelerate the scale up and I catch the weight.
Catch it.
That's the same thing as this lever accelerating the little weight on the end. It's moving it fast. That's why the weight will increase because of the acceleration. Here we go.
Well, then why didn't the 2 masses weight increase because of the acceleration? So that doesn't make any sense. I'm sorry, it just doesn't make any sense. You're talking here about pushing force you're applying based on how fast you move your hand. And obviously if I make that weight half as much, you can move your hand twice as fast. There's not going to be any difference. You're saying the half mass, if I put the half mass here, you won't be able to move your hand twice as fast and you won't be able to create the same effect. Of course you will.
What's it fucking say, you cunt?
Obviously, what a pile of nothing.
It's dark as fuck, I don't care. I fucking... You wanker. I'll fucking zoom you in, you bastard cunt. I can't see the fucking thing.
Show me how...
4 kilograms.
Show me how 2 kilograms behave any different. Show me how 6 kilograms behaves any different. Show me how you're saying the lighter things make more inertia. Lighter things are harder to push. That's what you're saying. You're saying that somehow half the momentum is lost. That somehow the half mass is so hard to push that it takes twice the energy to push it.
All because I've accelerated the weight. That's what inertia does.
No such thing.
Prick.
Asshole. So, did he explain anything? No. So I diagram the lever. I point out, well, here, what's your choice here? You're saying half the momentum. Levers don't conserve momentum. All right. It's a surprise to me. I think it would be a surprise to a lot of physicists if I told them levers don't conserve momentum. That every time you use a lever, you're losing half the energy, and it may be 3 times the energy if you do it put further and further out. So the more you use the mechanical advantage, the more energy you lose, the more momentum you lose. I don't think they believe that. So what a piece of shit video. Yes, that was not what. So again, as is too another misexplained, mistitled video. Another video where he can't possibly come up with a rational title that has something to do with the actual video. And this should have just said farting, farting. That's all he did. He didn't do anything responsive or intelligent. Alright. So maybe I'll just pause this and see and come back in the morning and well, 29 minutes is plenty. All right, I didn't think it was that long a video. All right, that's plenty of video. So waste of time. I guess I'll just say yes. Talking to Ian is a waste of time.